Hi everyone, welcome to, Hi everyone, welcome to our webinar today. I've myself here with you, and then with me is Augustine, and we will take you through some of the scanners we have available today and tips and tricks, and we'll through some rules at the end.
Okay, so just a few housekeeping rules. So in terms of your audio settings, if you joined this webinar listening through your computer audio by default, if you prefer to join over the phone, you must select use telephone after joining the webinar and call in using the available numbers. Then in terms of questions, please submit text questions by typing them into the questions section of your control panel. You can enter your questions at any time and we will address them during the Q&A portion at the end of the presentation. And then please note that this webinar will be recorded and then a recording will be sent out via email after the event. So we have the speakers over here. It's myself. I'm a reality capture specialist here at Modena. I have just over 6 years of experience in this field. Actually, an architecture graduate who made my way into the surveying field, and now I lead the team here at Modena for all our reality capture services.
Yes. I am Peter Burkhardt, you can see there, I'm capture specialist. I have about 8 years of experience of capturing various objects and environments. So anything from cars and boats down to oil rigs. I've been up north into Africa, not over the seas yet, but we'll get there one day. So my current role is a technical pre-sales. So anything related to food, when it regards to technical support or anything related to sales, you can just contact me as well as Nadine, who's head of sales for Para. Yeah.
So, for the topic for today, we're going to talk about bridging the gap between design and reality using 3D scanning, and then explore the potential that the different reality capture technologies has to offer, how accurate data bridges the gap between the virtual models and real world structures. On the agenda for today, we're going to discuss the types of laser scanners that we offer. So we're starting off with the FarrowFocus Premium and Farrow Orbis Premium. Then we have a little bit of a sneak peek into a scanner that we are launching soon. And then from the Matterport's side for services as well, we're hosting another webinar upcoming on the 31st of October, where we'll be discussing the Matterport solution in detail. And then moving on to how do we verify accuracy on point cloud datasets, and then some tips and tricks from the modeling team. How do we approach an as-built project? And then different types of value-added services, what you can achieve with your point cloud datasets.
Thanks. So on to the systems. So the two scanners we will mostly be talking about would be the Farrow Orbis, which you can see on the left-hand side of the screen, with an image of a data set behind it. And on the right-hand side, we have the FarrowFocus Premium scanner. You will notice there's a little camera at the top of the scanner, but we will discuss that very soon. And then also behind that, the Focus Premium scanner, you will see a little data set there of the quality that we can achieve with that scanner. All right, so for those people who don't know how 3D laser scanning works, so I'll just give a very quick brief overview. 3D laser scanning uses a laser that is being emitted from the scanner, and the object it reaches is returned, the laser is then returned to the scanner, and the distance being calculated to provide you with X, Y, Z coordinate for every single point that is being measured in that space. So there's different settings we use it as well, the resolution was. So we can scan from 11 million points, every million is 1.7 million points, all the way to 699.1 million points per scan. That's quite a lot of information. What the scanner then does after it does the laser measurement is it takes photographs up to 266 megapixels with the internal camera of the scanner. With the cam, you get 13 megapixel photograph from that. And then, yeah, that photograph basically converts to your point cloud at the end of the day with the RGB values from every single photo taken, placed onto the XYZ values of the laser scan dot to provide you this quality of data that you see on the screen. So what scanners that we have on offer from Modena side is the Focus Premium. That is just the basic scanner without any additional components to it, like the panorama that you see on the second scanner there. So that panorama allows us to do flash scanning. Flash scanning is awesome. We'll talk about that a bit later. Then we get this Orbis Premium. This is a new edition from the Orbis, a new version, the version 2, which sports a new as you can see there. And then we'll show you the teaser video or the new scanner that was launched. Right, on the Focus Premium scanner, we have three different models. We have the 100-meter Faro core scanner, the 200-meter Premium, and the 400-meter Max. The difference between these scanners really is the range. All scanners have the exact same specs throughout 1 millimeter accuracy on the scanning. All the photo qualities are the same resolutions on the scanner. Everything is exactly the same except for the distance. On the Focus Premium also, just talking about the specs a little bit, it does have a class 1 laser scan, a laser that it uses to scan. This means that it is eye safe, so it won't disrupt any people or any work around the scan itself. It will also note a 50% only visible. We do get to 50% of the scans with flash technology that we will also discuss later. And you get a 2-year warranty with scan, which is great for the Focus scanners. The previous ranges all in 1-year warranties, but the new series has got 2-year warranties with all confidence that Faro has in their machines. It's also got an IP rating of 54, which means that we can use it in testing and also in human environments. Just to showcase a little bit of the distance capabilities of the scanner, at the bottom you'll see that image in the back, where we have buildings on the very full end of the field. So looking at the image above them, we can see that on the left-hand side, the image quality, and on the right-hand side, we can see the point cloud information captured at that distance. So quite a bit of information.
Very impressive.
Yeah, at 400 meters there. So just to briefly touch on the Focus Premium, with the flash technology, you can see the camera there at the top. The camera is required mounting device, which we call the panorama mounts, to attach the camera to the scanner. And how this will work basically is the camera will take pictures to 180-degree pictures on the panorama within a few seconds, and then the laser scans. The scanner scans at 28 seconds within the space of that single scan using flash scanning. Very fast and efficient. This will increase your time increase your productivity, and with the stream application that you see there next to the scanner, that allows us to do on-site pre-registration. So you can be sure that you have captured the sites in the TBD. And if you see a little easily move back into that space, do a scan, and we'll add it to the registration for you. The accuracy on this always stays the same, up to 1 millimeter of accuracy on the flash scanning itself as well.
Yeah, Victor, we just had a question over there. So it's actually to ask the accuracy on various 3D scanning technologies like Faro or Matterport. Do you just want to mention the Matterport accuracies as well?
Yeah, so the Matterport, it does also have a LiDAR sensor like the Faro Focus scanner has, where the Focus scanner scans at 1 millimeter accuracy, and the Matterport was an accuracy on Matterport
10 to 20 mils,
20 mils.
10 to 20 mils, yes. And that's only on the Pro 3 model, yes.
The accuracy is complete. IR influence on using users, so it is filtered on the sunlight externally.
Yes.
Where the Faro Focus scan internally, externally, with as well as the Pro 3.
Yes.
Right.
Right.
So just to touch again on the flash scanning, what you see there on the screen, that is an image taken for 3D scan information from the flash scan. The flash scan does 28 seconds scan with HDR imaging. It was just, like I mentioned, with 1 millimeter, which you get 20 million points per scan. So there's a little bit of trade-off with speed and the amount of points that you can capture with flash scanning.
Yes.
Here's a video, just a comparison for you to showcase the speed of the flash scanning. On the left side, we'll see the camera scanner with the camera attached doing the flash scanning. And on the right-hand side, that's just a traditional way of scanning using the internal camera.
Not the pano cam.
Pano cam, yeah. So you see the on the left, see the big left, moving a bit on the right-hand side, and you can see the comparison there. Saving us up to 85% on scan time, depending on the settings, of course, but that's a lot of time saved on site.
Mm.
And you can capture bigger spaces in that amount of time with a lot more detail than traditional. So we have another question here. What's the turnaround time from scan to usable model on a core visual delivery? So we do have a study later on in the video. We will definitely answer that question for you. So, yeah, we'll get to that question for you in this later slides. Okay, so let's talk about the Orbis Premium. What is the Orbis Premium? So the Orbis Premium is a SLAM scanner. So it's a mobile scanner where we can hold the scanner in one hand, walk the site as walking in this. You don't have to run or very slow. With that, you will capture 640,000 points per second with the Orbis scanner. It also takes an image where it colorizes the point cloud, and you'll have that image as well at the end to view throughout the site that you have scanned. Right, so what is SLAM? For those who don't know, SLAM is the name for it is simultaneous localization and mapping. Sometimes they call it synchronized localization and mapping. But what this basically does is as you walk in the space, it will capture the surroundings and the environment itself and the surfaces, and that will calculate the distance between the scanner and the object and create the accuracy on that would be 5 to 10 millimeters with all the scanner itself. Right. Some benefits that we have on the scanner is we can scan a site very quickly. We can also scan a site within one scan loop, which is quite nice. You can scan a very large space in a couple of minutes, where the other way of scanning would take much longer. We have a lot of comparison for that at the end as well. And there's no registration required for the one loop scan. So the only reason why you would do the registration is if you do more than one loop on this area that you're scanning. Let's look at what are some differences between the original version of Orbis, the V1, and then the premium. So one thing that has been improved is the camera, where we had about an 8 megapixel camera in the V1 for Orbis. Now we have 29.5 megapixel camera photographs. This photograph quality is the every 1 second picture that it takes. But when we do flash scanning with Orbis, also possible with Orbis flash scanning, you can do that, and the quality of the image will be 72 megapixels. Quite a big improvement on that. And then it's also being used by the streamer. So you can see the screen itself, there's no screen available. You use the interface. The FarrowFocus Stream app, we'll also talk about that in a minute. That is your user interface where you can clearly see the amount of data that you've captured, and then make sure that you have captured all of it before you leave the site. Here's a very good example for you on the difference between the SLAM scan quality and the flash scan quality. So on the left-hand side, you can see the SLAM data quality. That accuracy on that is about 5 millimeters on the SLAM data. On the right-hand side with the flash, we get more detail out of that. Also, with the flash scanning, we get 20 million points per scan. And then also the accuracy on that would be 2 millimeters. So you can get terrestrial scan quality or accuracy with Orbis as well, with the flash scan technology.
Yes.
Here's another example of the actual 3D view of the flash scan that was taken. It takes only 15 seconds with Orbis. So a lot faster than the premium focus premium scan. It's got enhanced color by the new camera that has been added, and also good accuracy. Not as great as the premium focus premium scan, but there's a different application for both of them. And then, as I mentioned, 20 million points per flash scan. Just a very quick comparison between the version 1 on the left-hand side and the premium on the right-hand side, you can visually see the camera change. The rest of the scanner itself was kind of maintained the same, but the accuracy, the speed of the range that we can scan is 120 meters. For the flash scanning, it is down to 80 meters though, but we still get the image resolutions in outprinted, and we also have now an outprinted 54 on the scanning bit itself. So now we can take this into the mining industry, underground mining, and it can also provide us with that static 360 images. There's a nice little video for you to enjoy, where we have taken both data sets of Orbis and the InFocus scanner and overlaid them into each other, so you will see the change between the two data sets in the video, and then you can enjoy the quality that they have on the video itself. Some might be wondering where the Orbis will work and where the focus will work. As you can see in the video plan here, the focus provides us with more detail than the Orbis scanner. The Orbis scanner provides us with positional information. We can go into detail on certain objects by using the flash scan. But the majority of the use of the Orbis would be to do large data, capturing large sites. To capture that very quickly. And then we can always go back with the focus scanner and then add more information that is required in certain areas of the plant, for example. There we go. So what to use and where to use what? I mean, we've got the SLAM scanner that provides us an amazing speed, and then we've got the focus scanner that provides us amazing accuracy. With a mobile laser scanner, if you have limited time on site, if you don't need as great accuracy, if you need to scan a massive area, and you don't always have an expert available on site to do the scanning for you, the SLAM scanner is very easy to use. Take it in your hand, do your initial setup, and then just walk the space through at your own pace. No need to run or move fast, and it will capture that information very quickly. Where you need the directional scanner would be more detail on certain objects, a lot more clarity on the site of the scan. It provides us with a great image quality as well that can be used for measurements and so forth. And also the smaller area that you need, less tolerances for your screen size. So if you're looking for like millimeter accuracy, the focus scanner would be there for you. If you don't need millimeter but still fall within 10 millimeters, then the Orbis scanner would be perfect for that application as well. Here's a little test as with the traditional scanner versus the Orbis scanner, scanning the same site with your scans. On this one, you will see that 125 scans were done. The flash technology was utilized in this space as well. So it only took us 5 hours to scan the space with a 4-hour processing and registration. And then we got an accuracy of about 1 to 2 millimeters. And all of that was completed within 9 hours. Real scan took away calibration. Yes. With the SLAM scanner, we did one scan loop, still on the whole area. It took 30 minutes to capture, with around 3 hours of processing time. No registration was required, so everything was done in one loop. But the accuracy, unfortunately, is a little bit lower than the other one, with a 5 to 10 mil accuracy. But the time we have saved was almost at 70% that we saved by using the SLAM scanner instead of the focus scanner. Right, we have a poll question. The question for today: how do you manage large data sets from high resolution scans? And is cloud processing or local computing more efficient? We'll give you a minute to answer that all for us. Yes, Yeah. Let me just say the question. Right. Okay. I'm sure everyone has answered the poll by now. And we can move over to the new scanner that we are launching it on site the 4th of September. We're having an event for this scanner. We've launched this previously earlier in this year. And for us, for those who do not know about the new scanner, let's have a look. Okay, it's on. Apologies. There we go. So the new scanner is called the Blink. So we can scan it nicely, and it's really easy to use. It requires minimal training. It also utilizes the stream application. It doesn't have an onboard screen, as you can see there. But yeah, enjoy the teaser video in the next one. And we'll see you after
Ever
the
wanted to invest in laser scanning for job site documentation, but agonized over the cost or skill set required? At Faro, we've got a solution that's just for you. The Blink Imaging Laser Scanner is designed to be as easy to use as a smartphone camera. Just power on and start scanning. Follow the guided workflow, and with the press of a button, you're capturing job site data. After scanning, the data from Blink gets transferred to Sphere XG, Faro's cloud platform, where asset tagging and data alignment make your digital job sites info immediately actionable. Whether you're a contractor, builder, surveyor, or facility manager, Blink makes it easy for anyone to create detailed visual site records with the press of a button, and only minimal training before you get started.
exciting times with the new scanner. We will definitely go into more detail on scanner at our launch on the 4th of September. I believe Natasha has listed the link in for us for the launch date. So please go look at the launch date details and then register for the day, unlimited seats. And it also early bird catches the worm.
Yeah, exciting stuff, Peter. Something to look out for. So, what I wanted to talk about is more about how we verify accuracy with point clouds, because it's one thing to claim all of these accuracy levels, but it's another thing entirely to actually uh, go back and check your point cloud, especially if it's from third-party suppliers. How do I know that my point cloud is accurate as they claim? So one of the biggest advantages for you would be to get a surveyor out on site for some georeferencing. So the benefits of georeferencing is actually a fundamental practice. If you look back at survey measuring over the past decade or so. It's a very fundamental practice that we need to get back to, and it involves a surveyor going out to site, measuring some targets for you, and you placing your point cloud data set over that to check it against the georeference coordinates given by the surveyor. So it's enhanced spatial accuracy, because without it, the point cloud just exists in a virtual space, but adding real world context to that, we're using the survey coordinates and actually checking it against a third party data set, then it also streamlines your process going forward, because as soon as you have your point cloud georeference, then you will have your model georeference. Any coordination and collaboration that happens from the same survey network going forward. So there's no guesswork going forward. So what it would look like on site, especially for us, is we would require a surveyor to measure a few checkerboard targets for us. It's a very simple, easy process to follow. You can see there on the picture, it's just a few checkerboards added to site on various locations, distributed throughout the site so that we have clear coverage throughout the site. And then the coordinates can be given on a local survey system, and our point cloud can then be georeferenced according to that coordinate system. So another way you can check your point cloud is by taking it into your software and taking some snips, taking some sections throughout your point cloud. And then what helps is to put your different scan positions or different loops, in the case of slam scanning, in different colors, and taking sections and working through those sections and actually see, does this data line up? So as you can see there on the left hand, we had some interesting data sets across our table before, where you can clearly see a misalignment in that data set. And that's a clear indication that something has gone wrong here, terribly wrong here. And to go back to site, to go back and check the registration, to check the processing. Same over here. I mean, I can't really see where the flaw is there, but I can clearly see something is wrong. Send it back. Go back a step, take a breath, and redo that particular area specifically. Then some tips and tricks that I wanted to discuss is how, from our modeling team, how do we approach an as-built project? And then starting off with file formats and converting laser brand specific file formats to a file format that would be able to read and import into Autodesk software. So that would be converting it to an RCP and RCS. So a lot of the times we get data sets that's either XYZ or an E57 or a LAS file. And how do we convert that back to an RCP and RCS to be able to take the next step and creating an as-built of this point cloud data set? So I know we had this poll question. I think, are we going to put it up again just to get the answers out? So what file format do you typically deliver to clients, and how compatible are these within the BIM or CAD software? So do you use E57s, RCP and RCSs, XYZ or LAS files?
I can just add to that quickly. With the file formats, is even if we do get third-party information from another company, another 3D laser scanner distributor or manufacturer, we can certainly use that information and convert it into a usable file format for Autodesk software.
Mm-hmm.
And those steps are quite easy to do.
Yes,
Yeah.
yes.
Okay.
Okay, so let's see our answers over here. Looks like the majority are either new to reality capture, which is very exciting. Thank you for joining us. And then an RCP RCS, and I'm guessing that's predominantly because of the compatibility with Autodesk software. Yes. Okay.
Okay.
So thank you. Yes. There we go. So I just want to quickly take you through the process of how we actually convert XYZ, or in this case E57 files, using Autodesk Recap software to convert it from an E57 file. As you can see here, we're importing these files into Recap, and it's going to show us in a moment after the import of these scan positions what the point cloud would look like at the end of the day. Within Recap, so let's just index it over there. And it's the same data set that we actually saw in the fly-through video earlier on. Just a few scans, a scan with a terrestrial laser scanner that we imported into Recap over here, just to give you guys an idea of what it would look like. And over here you can see me just adjusting the scope box a little bit. Let's see if we can see some sections over here. There we go. And there you can see the different scan locations You can also go set different scan positions to different colors, to as I said, to do some QA/QC, to go do some checks on that. It's just visually easier. If you can see the scan positions in different locations, then you can automatically see between where there possibly is a misalignment, what data set is the misalignment from. And over here, you can see us jumping through some bubble views or panoramic image views in Recap, which is quite a useful tool as well. So that is actually showing the panoramic images that is captured with the point cloud, just to give you an indication of the interface within Recap. So over here, we're going to export this RCS thing. I'm just refining the spacing, but we're going to export. Obviously, we had E57s coming in, and now we are exporting it into an RCS file so that we have a compatible file to work with in the Revit for the next step. So over here, you'll see the export. There.
I just understand. It's always in the section of the point cloud as well. So you're going to have to export a complete RCP file to be used. So you can section it off into different smaller areas. And then when you export that and import them into Revit, for example, the location would stay the same.
Oh.
I do see that we have a question. Is Recap the best registration software? It's difficult to answer that without saying a few things about Recap. But so Recap is mainly used for it's a very cheap software, I would say, for registration, and it is there to make the point clouds compatible with Autodesk software. But there are other softwares out there that are stronger and that has more capability with registration and more options on the registration as well. So, for example, with Scene, we have about 5 different ways of doing registration. Where in Recap we only have 2, which is the automatic and the manual way of doing it. So there are benefits to using other external third-party applications then as well, or manufacturer-based applications.
I was about to add that to Peter. So, obviously, with registration software, Recap is written as a open-based type of registration software, where as you go into the scanner manufacturer, they actually write that processing and registration software specifically for the type of scanner that was used. So it's much more custom to the point cloud that you're going to deliver at the end of the day. But Recap is still a useful tool to do some manual registration and a quick registration, definitely.
It will still provide you with the point cloud at the end of the day, in the accuracy that you have scanning on site, basically.
Yeah. And then over here is how we then take the point cloud, the RCS that we just exported from Recap, and how do we set it up in Revit to start the modeling process. So over here, you can see the same data sets. And what I just did is I established some levels, some grids, everything throughout the building, just to kind of start piecing the puzzle together and getting that information in there. I'm going to hop through on plan view over there, and then on section as well. You can see the level of information that you're able to obtain from a point cloud data set, which is very, very, very impressive. Again. So let's talk a little bit about data cleanup. I think everyone who's been scanning for a while has seen a noisy data set and the frustration that goes along with that. So what is noise? So noise is any unwanted points that are generated within the data, and the causes for the noise are vast. It can be reflection, it can be moving objects, it can be the materiality or the temperature even that you're measuring against. But it's always, as a fundamental practice, best practices to minimize the amount of noise. And the way we do this is actually cleaning up that noise, removing that noise from your data sets. And the reason we do that is to ensure you have a clean data set, to minimize any uncertainty. So there's no guesswork Is this a pipe? Is this a reflection? Is this what's happening? Is my bathroom actually on the other side? No, it's scanning through a mirror. Um, and then obviously to decrease the data size at the end of the day. And then better value added services. So for BIM extraction, the cleaner point cloud you put in, the better product you're going to get out at the end of the day. And then also removing sensitive data. So for instance, if there are any people in this in the area, if you want to remove them, or any number plates or specific building information or addresses or anything like that, sensitive information that you don't necessarily want to distribute to any third parties, you can take that out.
So if I can just add on that part of cleaning and recap specifically, is when you remove point information, point data. So for example, if someone's face was scanned, when you remove that information you save, you can update the photographs as well to then completely remove that from the data. So not only the later scan data, you can remove sensitive information, but the photographs as well.
Also in the pictures, yes. So that's a feature that Recap added fairly recently. Yeah, fairly recently, which is a very, very useful tool to actually remove that sensitive content out of the photographs as well. Okay, so moving on to the value added services. So what can we achieve with the point cloud data and how do we convert it into information and deliverables? So over here, it's a fly through of exactly the same data set that we just showed. It's the office park. And this is what we would consider a basic architectural model. So just a quick fly through, you can see there's no materials necessarily added, but your basic building information is there. So your walls, your floors, your windows, your doors, your columns. Here we added a little bit of furniture layout as well, just to do some spatial planning. But you can see the level of information that you're able to obtain from that over there.
It's quite a lot.
Yeah.
See more details.
Yeah, so this was done by using the point cloud dataset, importing it into Revit, and then developing a Revit model from that dataset. So we have another poll question coming up now. So do you use automated tools for registration and modeling, or is it a fully manual process? It's a very good question if you don't mind answering. Okay, looks like we're experiencing some technical difficulties over here, but let's just chat about it. So do you use automated tools for registration and for modeling? So in terms of the registration, I think Peter can touch on that.
So you see that it's got this amazing automatic registration feature where you can do top view based registration. Very quick way to just make sure that I see all questions now live, so thank you. You can answer there as well, but I will still continue with my explanation. So we have a top view based registration, which just basically places the scans in its correct position of where I've scanned them on site. And then the cloud count at the end would be to refine that registration, just to bring that accuracy down to where it needs to be, and then provide a very clear, smooth, all-to-all accuracy registration. Apologies. And then, yeah, there's other ways as well for automatic registration within Scene. But yeah, that's the steps to follow.
Yeah, and then in terms of modeling as well, it's very user dependent at the end of the day. You do get automated software for modeling specific applications. And it's definitely useful to use that. But we have found that in terms of going back, running the automated process on the modeling side specifically, running that automated process is one thing, but then actually having to go in and go check where verification of that model is quite time consuming. So that is very, very user dependent, I would say. So we have a couple of questions over here. Can you run clash detection with your point cloud and Revit? And what would be best? Yes, you can. You can do that within, or just manually checking it against your Revit model, or your building model against your point cloud data set, or you can import that into Navis as well. Yeah.
Detection, specifically built in
Mm.
for point cloud, clash detection with point cloud modeling as well. Definitely possible to do that.
Yes. And then another question we have here is, how do you demonstrate return of investment from reality capture to clients who are skeptical about adopting the new tech? And that's a very good question. How do we promote the service? And then honestly, it's about you selling the value of the service. It's about you selling the information that you're going to be able to obtain from that. And eliminating any guesswork for future consultants as well. If you go in, you scan a site, you have all that information available to you, and you are able to bring that information back to your own office. You don't have to, in the days of going and measuring by hand or all this survey methods, you don't ever have to go back to sites because of a slight human error. You eliminate all of that possibility, all of that risk. You have all your information and the comfortability of your own office space. So it's about selling the value of that.
Yeah, once you can just you can use all of the information is available for the modeling process, which then will also speed the process because you have like a visual of the site in 3D in Revit. So very quick turnaround time with point cloud than it is doing it the old manual way.
Okay, so over here, same office space
Yeah.
that we then started off on the visualization. So as you can remember from our previous fly-through video, the level of detail that was in there, it was very basic architectural elements, no finishes, no anything, just building elements included over there. And then how we stepped it up to actually add some more information within this model. You can see the ceiling panels, the MEP, the furniture layouts, all the finishes on the floors, the carpeting, even the blinds and the everything like that was added as well. And then this is a service that we also offer in terms of visualization, to help clients with their renders and fly-through videos to be able to market their work better. Yeah, and the software that we used doing this was Twinmotion, which is also compatible with your Revit project. Just a plugin into your Revit project. Very, very easy. Very beautiful renders we can get out of there. Okay, so over here onto the exciting part.
That's just the answer for Sally Jones. What's the turnaround time from scan to usable visual or visual delivery?
Yeah. So to answer that question, we really need to look at the level of information required. So at the end of the day, you can stage it and phase it in such a way that the level of information that you need, the more information we need to populate within your Revit model, the longer it's going to take, because the more time consuming that's going to be, and obviously the more expensive it is going to be. So it's really understanding your client's needs in terms of, are we doing this just for a spatial layout? Are we just going to do a basic LOD1 building just to show geometric positions and do kind of a space plan, which we can do quick and easy? Or are we doing a basic architectural model at the end of the day where we want certain building elements like the windows, the doors, the floors, everything indicated? Or are we stepping it even more up from there? Are we adding structural components? Are we adding mechanical, electrical, and piping components? Is that some of the information that we would need from there? So in terms of turnaround time, I think on the scanning side, it's fairly easier because we capture everything with using a scanner. Yes. Everything you can see, everything the eye can see, we can see. So what is am I going to put you on the spot if I ask you about if I ask you about the square meterage we're able to cover within a day, let's say?
So square meterage wise, and also depends on the environment that we are scanning. So let's use architectural for an example. We can do about 2,000 to 3,000 squares in a day. Also dependent if we're scanning for services and in-ceiling scanning. I see that we have a question that I'll ask you now regarding the in-ceiling scanning. But when we move into the more engineering space, plant space, so forth,
Condensed.
condensed, highly populated with equipment and so forth. That complicates things a little bit in the sense of we need to do more scans to capture all the angles of that space. With that, we can cover about, depending on the complexity, 1,000 to 2,000 squares in a day. Yeah.
That's some good numbers just to give you an indication of what it is we're looking at over there. Do we want to take this question? What about hidden elements in ceiling voids? Can you capture that?
So the scanner is line of sight scanner. So what you see, the scanner will see. So if we have space to move into the ceiling space, for example, we can remove ceiling panels and then hoist the scanner up high enough to fit into that ceiling void and then scan that. Definitely we can do that. Or the other alternatives are if it's a walking ceiling. If we have
Which is
space to
preferred,
walk,
obviously.
yeah, then we can definitely scan that much easier than a normal ceiling in a residential area, for example. Definitely possible. And also, there's normally not a lot of lights in some lighting. So
Would that affect us?
yeah, so that will be quite the dark space to scan. We just turn off the camera option of the scanner and then we do a laser scan without it.
Yes.
So then we are just presented with a grayscale point. And the focus scanner, it can scan in 2% light. I mean, that's really little light.
Yeah.
I mean, if I've scanned underground, just a very quick example, where there was absolutely no light. But the scanner saw everything. It saw all the little nooks and crannies that I've scanned there. I've got detail and the accuracy that I require in block spaces as well.
Yeah. So just the laser doesn't need any light to do the capturing, which is amazing. So we're going to discuss a quick case study at Terfontein Racecourse. This is a project that we completed earlier this year. For those of you who don't know, it's a horse race track based here in Joburg in Gauteng. So the project brief was for us to assist with 3 reception areas within this race course. So there was the Aquanaut elevation and centenary reception areas, and we had to go in, do the site capturing, go out with scanners and actually capture the information, come back to office, do the 3D architectural modeling, do some plan extraction. And the reason for that is that this was an interior architect, and he was very much still paper-based. So he wanted us to extract the plan so that he could do his design intent, still pencil on paper type of architect, which was amazing. So we sent it back, the information back to them to go do their designs and alterations to these spaces, and then they sent their designs back to us, and we assisted them with the visualization of this project. And all of this was done in 2 weeks.
From scan to modeling.
From scan, modeling, design changes, and rendering. Final handover within 2 weeks. Amazing stuff. So over here, I'm just going to show you one of the reception areas over here. So there you can see just the overview of the point cloud model, and obviously a colorized point cloud model using panoramic images to create a colorized point cloud for us. This is actually the quality of the panoramic images which we were able to obtain from from the laser scan, which is absolutely incredible if you look at that detail. Yes. And just to show you just a comparison between the point cloud information and then the panoramic images, you can see the differences there. And then moving over to actually taking in this point cloud into Revit and doing some architectural modeling for them. So you can see that those detailed ceilings, all the MEP lighting fixtures and everything in there. Very, very basic architectural model that we sent over to them. And then after their design changes, this is what we ended up with in terms of the visualization. So once again, using Twinmotion to create these renders for us, showing their design intent. And then I'm going to take you through a few areas, and this has actually been completed. So you guys can go over to Terfontein to go have a look at the end product. Very impressive if you compare the before and the after with one another. And just as a note, to look at the amount of detail which we added within this render, if you look at the light fixtures, and then also the materiality, like on the tiling, the different colors, textures, everything that was used to create this space.
I think there was they call it live wall, plant wall.
A plant wall, a live wall, yes.
So maybe on the right hand side of those different colored tiles, there's a wall there as well, which is like that on site as well. But after they all design change that happened.
You can see the textured wall there at the bottom, the scallop tiles, absolutely magnificent detail that they added within here. So at the end of the day, we went back with the client to site to go present to their clients this design. And this is the feedback that we got from them. We used a Oculus, a Meta Oculus Quest, to go present these in a VR experience for the client. So just some feedback that we got is that the VR walkthrough and meeting on site at Terfontein was a resounding success. We presented to some high power execs and committee members, and the decision was unanimous to adopt the new design for the project going forward. We are so grateful for your expert and professional involvement in this project and can't wait to embark on new projects in the near future. So yeah, the advantages of actually having that ability to go with a VR walk set to actually stand within the space and looking around and seeing what it is going to turn out as very, very, very advantageous. So we have a question over here. Do you have scanners I can rent? Yes.
Yes, we do have rentals available.
Mhm.
We can definitely get in contact afterwards and then discuss the rentals.
Mhm.
Our rental scanners are available for how many days ever is required for your project. We also offer the services, just to mention, for the registration, if you don't know how to do the registration of the rental scans that you have done. But definitely you can do that on your own as well, if you have that experience.
Yeah, and then maybe to add to that is that we also offer the training services to actually help the clients get familiarized with the technology, with the scanner specifically, and train them up in the use of the laser scanners.
The training is just two sort of training. On the scanner itself and how to operate the scanner and best practice and so forth. Where the second day would be based on the software, taking the scans you've done first day and work that data to get to the end of the deliverable. So yeah.
So yeah, and then another question we have here is where do you see the future of 3D scanning and reality capture heading in over the next 5 to 10 years? That's a very good question.
Good question. I would say that traditional is going to fall away completely. Everyone should be using a 3D laser scanning. I mean, the accuracy is there, the data quality is there, the photograph information is there. Hard to reach places you can capture. With the scanner range, if you have a building and you need to scan the facade, how are you going to measure that in one hand? So the
Mm.
laser
Possible.
scan data will provide you all of that information of the facade of the building. So I don't see the scanner falling away at all. It's just going to get more
It's going to improve.
getting improved and being adopted by these industries within the near future.
Yeah, I also see just a exponential improvement in terms of the speed and the accuracy that we are able to going to be obtained from laser scanners. Okay, so sorry about that. Just to mention over here, we also offer the Matterport solution as well. So the Matterport Pro 3, Pro 2, we mentioned it briefly, but we are going to discuss it in depth on the 31st of October with our next InFocus event, and then specifically tackle digital twins with the Matterport as well. So we compiled some frequently asked questions that me and Peter have been asked numerous times. So we thought we'd add it in here just to give you guys an idea over here. What lessons have you learned from difficult or failed scans?
I would think the first lesson is to make sure that you have site access. If you don't have site access and you can't enter a space, you can't scan it, then we have to make assumptions, which are not good at the end of the day, and that's why we use the scanner to not make assumptions. The other thing I would say is that if you're in doubt, if your scan position is going to work or not, do one more scan. You can never have too many scans, and it will always help you in the sense of not returning to site again to do more capturing of data. Yeah, so those are the biggest components for
you.
difficulties on sites.
Have you had instances where your scan helped identify critical construction errors or misalignments? And that, I think this is a question for me actually.
Yeah.
Yes, we have. That is actually one of the most popular services that we offer is to go out and go measure a building up to go see any discrepancies that we have. And one case study that I can show you guys is actually the Bel Ombre train station, which we did in Pretoria. Very impressive project in terms of square meterage, and in terms of that roof, the amount of detail that we had to add in the modeling side as well. And just as a note, maybe to add, we actually captured this only from ground level. Because of the scanner range and different scan positions, we were able to obtain that information using only scan information. And then the modeling elements as well. So the reason they brought us out was due to the roof degradation and some erosion, some theft, everything like that. So they really wanted an accurate representation of the roof structure as it is, which was a very interesting project.
So, yeah, the next question on our frequently asked list is how do you handle fusions or blind spots during scanning, especially in complex environments? So that's where the stream application comes handy. So as you're doing scanning, either your Lucas or Orbis, you will be presented on your cell phone or the tablet, what you're using, the resolution top view data from the SciJ scan.
Yeah.
So as you can see on the stream application, there are certain scan positions with a circle with a tick mark inside there. That is our scan positions. So if we can clearly see on them if we have missed a certain spot, and then we can easily move back and complete that scan for us, providing more additional information. And this also ensures that you're done with everything when you leave the site. So you do not have to return to do any more scanning. Then next question is, can scanning also be used to produce immersive AR and VR experiences for clients or stakeholders?
Yeah, and as I already mentioned, we had this case study where we did the VR experience presenting to our clients' the design changes and alterations within that space. And I don't think there's enough emphasis on the benefit of having a VR experience of your design intent. Actually, yeah. So definitely possible with point clouds, with Revit models, and with visualization,
Very much.
rendered images. Yes.
So I think this last question on the list is, when do you deal with environmental conditions like dust, poor lighting, and outdoor elements? So with the scanning being rated IP54, we can scan in almost any type of environment. So you can see this type of environment with a lot of humidity and so forth. So scanning can handle any type of environment. Dusty, humid, lights, long lights, it really discriminates in that sense. Okay. I see we do have a question. If you have a large project or site, do you think survey control is important?
Yeah. That's a very good question, and yes, that would be very, very important. You need to establish a survey control throughout your sites. It's just to serve as an independent check against your own point cloud data set as well. So the benefits of having a survey control network is, yeah, can't be overstated.
So you just need to just check and verify the drinking is also included towards the survey or is taken. It's just a double check on the sites.
And then having an actual geolocated point cloud Revit model, everything downstream geolocated, absolutely amazing.
Okay. There's not any other questions. I do not see anything else so far on the question list. If you do not mind, you can provide us with feedback on a QR code, and there should also be a link in the chat for to access the feedback form. For those who fill in the feedback form today, we'll get an email with the discount link. We can't say what that discount is for at this point, but you will receive a discount. So please provide us with feedback, and it's always able for us to improve our services. Yeah, and you will get your discount link by the end of today. Right. Thank you for everyone who joined. Thank you, Augustine.
Yeah, thank you, Peter.
Okay.
Okay.
Great weekend.
Yeah. Thank you, guys.
Thank you all.